All right, hello everyone. I'm going to do another Leetcode today. I'll be using a Google Doc even though it sucks. It is one of the ways that interviews sometimes go, and so it's good to practice it every so often. So let's try doing an algorithms question. We'll choose an easy today, and we'll pick one at random, and let's start the timer. All right, so what do we got? Number 2744, find maximum number of string pairs. You are given a zero-indexed array of words consisting of distinct strings. The string words of I can be paired with the string's words of j if the string is equal to the reverse string of the other one. Here, I and j, I is always going to be less than the length of j, and j is always going to be less than the words dot length. Sure. Return the maximum number of pairs that can be formed from the array words. So we don't actually care about which pairs they are, we just care about the maximum number of pairs. So note that each string can belong in at most one pair. Interesting. Okay. So one of the things I'm thinking about here is if a string is equal to, can be paired up only with the reverse of itself, then if there was another third string that was the reverse of one of the two of them, then it would be equal to one of them. It would be the same. And so obviously we would have a mismatch, like not a mismatch, sorry, an overlap between the two of them. But you can only have at most one pair for each string. Return the maximum number of pairs that could be formed from the array words. So is the input array ordered is one of the questions to be asked. It doesn't look like it here. Let's see. An example. Words, these pairs of characters, CD and DC, for example, are pairs. AC and CA, and ZZ is not. So we kind of already know if a word's is length n, we can never have more than the floor of n over 2 pairs. That'll always be the max in the perfect case where every single pair exists. If the length of this array is less than 2, then it'll always be 0. Those are some edge cases. Here A, B, and BA are 1, and C, C is not. Here there's none. Question would be, how long is the list of words? It'll probably fit in memory. In this case, there's only up to 50, and the length of each word can only be 2 max is guaranteed in this situation. That's kind of interesting. So if it wasn't, we would have some sort of like, let's say in the perfect world, in a perfect world, we'll have to check every single string, no matter what, because it's not ordered. So O of n for the number of strings. Let's start with writing that out. And let's say k is equal to length, max length of a word, which is 2 in this case. So in a perfect world, it would have been something like O of kn time to check every word once. But yeah, I don't think we can do better than that because we don't get an ordered string. Space complexity, technically you could probably get it down to O of 1 because you only need to keep track of the number of pairs. You don't actually need the pairs themselves. Ideal case, O of 1 space. I think we can get there. Yeah, so it looks like it's interesting that the word's length is only equal to 2 and contains only lowercase English letters. So let's talk about ways we could approach this. I think the one that's kind of jumping to my mind first is just some sort of hash map or table. So let's call this hash every pair. So for every word, place in hash map sort. So how do we want to check if a pair exists? If this was a long length string, we'd want to create some sort of unique identifier for a string and its reverse string. It could be whichever of the two of them is the lowercase, if it's AB, if there's AB or BA, then AB is the one we choose, and we store it in as the key into the hash map based on AB, like the sorted version of it. Well, not sorted, but reversed, so that it's the lowest possible letter to start. Because there's only 2 letters, we don't even really need to do that. Check if string or is. Check if first or last letter string is lowercase, lower ASCII code, A before B, is earlier in the alphabet. Reverse as needed. Then insert that into the table hash map. If it already exists, delete from the array, the map, and increment the counter. So basically the idea is we build up every word into a map and check if its reverse exists, and if so, we remove it from the map because we found a collision, and then that's one pair that exists now. However, if you have, well, no, that'll handle like AB, AB, BA, BA, because they'll both collide with each other once each. But the problem there, so let's just talk it out loud. So let's say we had AB, AB, B, BA, BA, like that. What we want is to pair up every A, B, and BA twice. I don't think we actually have to worry about that because right now they promise us that each string can belong in at most 1 pair, so there'll never be an overlap. Or is that true? I think we might be allowed to have repeats. This is consisting of distinct strings, so there are no repeats. Okay, so we don't actually ever have to worry about this. So I think we can just go across with that approach. Approach 2, instead of hashing every pair, we could sort the array and then check the first letter and then the second letter with every other letter. I wonder if there's anything interesting we can do because there's only two letters per string. We have kind of fixed number of characters. There's only 26, so 26 times 26 possible. There's only that many possible combinations. I wonder if we can do something a little bit more clever than the first approach. For example, we have a list of 26 spots, and that'll be the first character. And then we check for when we get to a, let's see, like 0. This will be like A, B, all the way to Z. And then each of those will have, each entry has 26 possible zeros. And we iterate through the array of words, and we increment the value inside this 26 by times 26 list. And then we check whether the opposite ordering of those words exists in this array. And if so, then we have our pair and we can remove it. This is kind of like doing a manual hash map that has all the entries existing, but we no longer need a hash map. We have a fixed size array. So one could argue it's O of 1 storage for that. Though it's kind of the worst case. I don't know if that's any better. So let's not go with that either. Let's just start with the array 1. So how would we do that? Should be, let's call this get max pairs. And our input's going to be words, which is a list of string. And our output's going to be an int for the number of pairs. So if length of words is less than 2, return 0. That's kind of our base case. Otherwise, we can build up our pair map, let's call it. And then for word in words, if word of 0 is greater than word of 1, then we reverse the order of it. Word key equals, let's call it reversed if it's the same. We'll reverse the word or the string if its second character is smaller than the first character. Otherwise, we just put it in as is. And then we check if it exists. And we'll create a count. So if the key is in the pair map already, then we can just remove it. Which technically we shouldn't have to do just because we will never have any pairs, all the strings are distinct. So we might not need to do that, but just for cleanliness, I'll put it in there for now. And if it exists, we delete it from the key, we increase the count by 1. Otherwise, we add it into the pair map. Actually, we don't even, it doesn't even need to be a dictionary. This can just be a set. Pairs, pair set. Let's just call it pool. Let's call it a pool. So if the word key is in pool, then don't need to remove it anymore. Otherwise, we add it. Whoops. Okay. And finally, we just return count. So this isn't the cleanest thing yet, but let's just start. Let's just go with this for now. Right now, we have O(n) for the number of words. We're flipping the order of the word if necessary. This would be an O of K operation, but that just becomes O of 1 because it's a fixed length word. Checking if it's in the pool is O of 1. Technically O of K, I guess, because of the length of the string. And incrementing count, otherwise adding it to the set, also O of 1, finally returning count. So we get an O of n, O of 1, O of K, and O of 1 solution. Okay. Does this fit? Are there any edge cases to think about here? Wonder why they had to spell this out. Am I missing anything here? The ordering matters. Is that what they're trying to say? I is always less than J. No, that's fine. You're allowed to do it the opposite order. Max number of pairs that can be formed from the array of words. We don't have to worry about any weird loops because they're 2-letter words. There's only one possible pairing. Okay, let's try it. Let's see how it does. I have to remove all the tabs when I do that, so that's why I'm doing it this way. Okay. Okay, let's have a look. Seems to pass the test cases. That's a good sign. All right, let's try submitting it. Ooh, we have a mistake. Okay, what's going on here? When we have ZS and SZ, that's one pair. And we're getting a 0 instead of 1. And PPIE do not matter at all. So why is SZ and ZS not working? Strange. I may have messed up the ordering of this, it sounds like. So let's see. If word of 0 is greater than word of 1, ZS, it's true. So then we reverse the order, it became SZ. And that's the word key. Oh, pool.add word key. That's what it's supposed to be, not add word. All right. Let's test that again. That was a mistake on my part. Because if you add the word, it could be in the wrong ordering, and then you're not checking for that correct ordering in the word in the pool. And the only reason we passed these test cases is because it happened to have the smallest ordering first, whereas here ZS came before SZ. So now this should just work. Let's have a look. Yeah, there we go. Good to see. That was a little foobar right there, but good to catch. And don't worry too much about the timings. You want to be in the general ballpark. Especially for easy questions, the speed is to do with the computer rather than the backend that runs the test, rather than the actual algorithmic complexity a lot of the time. Okay, pretty cool little question. I think it'd be interesting to extend this to deal with words that are larger than just 2 characters, and also to allow for cycles or repeats. That might become a medium question associated with this. If so, I'll link it below once I get to that one. Anyway, in the meantime, have a great day, y'all, and see you guys next time.